Alright, we've taken a look at percent composition. Now we're going to take a look at empirical formulas. But in order to talk really about what an empirical formula is, we have to compare it to a molecular formula. So there's two types of formulas. What we've been dealing with so far have always been the molecular formula. An empirical formula, though, is the smallest whole number ratio of elements. So an empirical is not an actual count, it's just a ratio. The molecular formula, that's the one we've been talking about for since the beginning of the year, really. That's the true number of elements that are in the compound. So the empirical formula just tells us a ratio. A molecular formula tells us the actual count. So to help you kind of see the difference, I'll tell you about one of my chemistry classes. So in one of my chemistry classes, it is 60% female and 40% male. So there's our percent composition of the class. So that means that the class as a ratio, if it's 60 and 40, that means it's a 5 to 3 ratio. Okay? Doesn't mean that there's 5 girls and 3 guys. Okay, there's definitely not only 8 people in that class. So it's 60%, 40%. That means it's a 5 to 3 ratio. So if we were to write the formula for this, that means it'd be F5M3. So it looks just like a molecular formula. This looks like a chemical formula, F5M3, but it's just telling us the ratio. So this right here would be our empirical formula, because it's telling us that there's a 5 to 3 ratio of guys to girls. Then if you were to come in my classroom and actually count it out and see how many girls and how many guys there actually were, you would find out that there is 15 females and there is 3 males. 10 males. Okay, so then the molecular formula for the class would be F15M10. So our percent composition tells us what percent of each there is in the classroom. And a 5 to 3 ratio means that there's F5M3 for the empirical formula, which just tells us the ratio of guys to girls, or atom to atom. And then finally, when we get the actual count, F15M10. And so that would be the molecular formula. So when you look at a molecular formula, you're seeing how many there actually is of everything. Anytime that we talk about empirical formulas, this is what we mean. And this is just a stepping stone to get from here to here. So scientists use this just to go from here to here. You would never use this in balancing chemical equations or anything like that, just for finding out what the molecular formula is. So here's an example of an empirical formula. Well, this is hydrogen peroxide, H2O2. We've used that in a couple labs. H2O2, that is the molecular formula. So I'm just going to write MF. That is the molecular formula. So there's actually 2 hydrogens and 2 oxygens for each molecule of hydrogen peroxide. So what is the empirical formula for this then? What is the ratio of hydrogen to oxygen? Well, it's a 2 to 2 ratio, and 2 to 2 means it's really a 1 to 1. So for every 1 hydrogen, there's another oxygen. That means the empirical formula would be HO. That just shows that there's a 1 to 1 ratio. It doesn't tell us how many different hydrogens or how many different oxygens there are. So, and something to note for this, then what about something like H4O4? Okay, that's another molecular formula. That means there's 4 hydrogens and 4 oxygens. What's its empirical formula? Well, its ratio would be 1 to 1, so its empirical formula would also be HO. So empirical formula, that's why we can't just stop there, because it can describe several different compounds. Any compound that has a 1 to 1 ratio of hydrogen to oxygen is going to have the same empirical formula. And so we have to use molecular formulas then to really describe what a molecule looks like. So then what would the empirical formula be for C6H12O6? Pause the video, see if you can figure this one out, write down the empirical formula, then resume and check it out. Okay, so if we look here, it is a 6 to 12 to 6 ratio, which can be reduced to 1 to 2 to 1. So the empirical formula for this would be C1H2O. And there's several other compounds that can have this same formula, or the same empirical formula. So if we had something like C12H24O12, it would have the exact same empirical formula as this guy right here. So it just tells us the ratio. That's all we're looking at.